Alright guys, good morning. Welcome to attend my MIS class. Alright, in the last class we have discussed the differences between file-oriented and database approaches. So starting from this class, let's examine some fundamental concepts in the database approach. The dataset concept discussed earlier is a crucial building block of database models and as well as the database system. A dataset is created for every entity and every event that needs to be represented in the database. So first of all, here are some basic concepts that you need to know. As I introduced earlier in the early chapter, you may have been familiar with the concept of primary key. And again, primary key is a unique identifier of a record in the file. Well, please be noted that it must be a unique identifier, such as your social security number, such as your net ID at Rutgers University. These primary key must be unique to uniquely identify only one person in the world, or in terms of database, it must be uniquely identify one record in the database. So in the database, every dataset must have a unique identifier of records within the dataset. This unique identifier is referred to as the primary key of the dataset. When multiple fields are used to uniquely identify a dataset, the result is as a composed key. Well, it also works to identify a unique record in the database, but we use more than one field to uniquely identify one record in the dataset. This is composite key. Next, non-key attributes. Well, every field in a dataset other than the primary key is referred to non-key attributes. Some of the non-key attributes may be used to sort the file to facilitate answering user queries. As discussed earlier, a unique aspect of the database approach is the interrelationship between datasets. These interrelationships are defined in different ways depending on the type of database model. In terms of our discussion of case, it's relevant to discuss the concept of foreign key. So here it is. A foreign key is a field in a dataset that is the primary key in a related dataset, referred to as the master dataset. There are two variants of the foreign key concept. A foreign key can either be a part of composite primary key or simply a non-key attribute in a dataset. That is, when the dataset has a composite primary key, then each individual element of that composite key will usually be the primary key in another related dataset. Alternatively, a foreign key can simply be a non-key attribute in a dataset, which happens to be the primary key in a related dataset. It is important to identify foreign keys in a database because it is foreign keys that enable linking of the datasets that are related to one another. The concept of foreign key will be explained later in this chapter using an example. So personally, I would say the foreign key is the connector, of different data sets, or simply speaking, different tables in relational database model. Okay, relationships between entities and events, both of which are represented in the database by means of data sets, can be of three types, referred to relationship cardinality. Well, these three types are one-to-one, one-to-many, and many-to-many. These are three relationship types. The shorthand of depicting each relationship type is shown in a pair of brackets. Well, consider a relationship between the department and manager entities. These two entities, department and managers. Well, a one-to-one relationship between departments and managers means that each department can have one and only one manager, and also one manager can manage one and only one department. So again, a one-to-one relationship between department and manager means that each department can have one and only one manager, and each manager can manage one and only one department. So this is one-to-one relationship. Now consider the relationship between salespersons and customers entities. These two entities. The relationship between these two should be one-to-many. So the one-to-many relationship between customer and salesperson basically means that each salesperson can have many customers, but every customer is assigned to exactly one salesperson. Please note here, a one-to-many relationship can be interpreted as M-to-1 relationship when read from the opposite direction. Thus, the relationship from customer to salesperson is M to 1, which means many customers can have one salesperson. And next, many to M, many to many. A many-to-many relationship between salespersons and customers indicates that each salesperson can have many customers, and each customer can work with many salespersons. Well, another example of the various relationship cardinalities, consider the relationship between students and tutors. A one-to-one relationship indicates that each student is assigned exactly to one tutor, and each tutor is assigned to exactly one student. A one-to-many relationship from tutors to students indicates that each tutor has many students, but every student is assigned to exactly one tutor. So this relationship would read as M to 1 or many to 1 relationship between from students to tutors. And a many-to-many relationship between tutors and students indicates that each student can have many tutors, and each tutor can also have many students. So in this case, M sides of relationship means many sides and can be interpreted as one or more. Well, now let me formally introduce what a relational model is. The relational model, uh, the relational model, which was first produced by Professor E.F. Codd, uses the concept of relation to store data. Well, a relation is simply a two-dimensional table with rows and columns. The rows the rows is also referred to as tuples, means the records in the dataset. Well, the columns are referred to as fields. So, and the term table and relation are synonyms. And these two terms, table and relation, can be used interchangeably. Henceforth, in this book, we will use the term table rather than relation, and rows rather than tuples. A customer dataset would be implemented as a two-dimensional table with the columns containing the various attributes of customers and the rows containing the records. The concept of table is intuitively appealing and easy to understand. Then a series of tables are constructed for storing data relevant to the situation. A relational model for sales order and collection system is shown in these slides. Well, actually, this is a, a table, but it doesn't look like a table because this is the way how you represent a table in relational model. Well, let me introduce this table to you. Well, the resulting table have these different fields: sales regions, customers, sales orders, items ordered, collections, order collections, and item. And if you can see the arrows in the figure are drawn to point out the links between tables. The single and double-headed arrows signify one and many relationships as before. The convention we will use to indicate the primary key in the table is by underlining it. Obviously, there will be two or more fields underlined in the case of composite primary key. So in other words, the fields that are underlined means the primary key. If you can see more than one field underlined, well, it simply means the composite key. So in this data set, we can see 7 tables with the field names in the pair of brackets, and also with the primary key underlined here. If you can recall that we introduced the concept of foreign key earlier, let's revisit the concept in the context of relational model. Well, to repeat, a foreign key is either a non-key attribute in a table that is primary key in a related table, or an element of composite key in a table that is primary key in a related table. The related table is in fact the master table of that key field. Well, let's see. In this dataset, the customer number listed here. Customer number and region number fields in the in the customer table and sales table. Working together, they serve as the non-key attributes in sales order tables. Well, as you can see, the customer number and the regional number are primary keys in each of the customers table and sales regions table, but they serve as non-key attributes in sales order tables. Well, this is actually an example of the foreign key. So regarding to customer number, customers table is considered to be the master table. And similarly, for the region number, sales region table is considered to be the master table for the region number field. Now, let's turn to the second variant of foreign keys. Those that are elements of composite primary keys. Okay, let's see. The orders collection table has a composite key of receipt number and order number. Order collections table has a composite key of receipt number and order number. Per the definition of a foreign key, both receipt number and order number are each considered to be foreign keys in order collection table, since each of them is a primary key in the related master table, where receipt number is the primary key in the collections and order number is the primary key in sales orders. Well, similarly, order number and item number are the foreign key in the items ordered table. The relevance of the distinction between these two variants of foreign keys will become apparent a little later in this chapter when we discuss the concepts of entity integrity and referential integrity. The convention we will use to indicate foreign keys in the relational model is with a asterisk at the end of the foreign key field. Well, in relational model, many-to-many relationships are represented using composite key tables. So the many-to-many relationship between sales orders and collections is implemented by creating an order collection table, which has the composite key comprising the primary keys of the sales orders and collections table. So that is the two tables involved in these many-to-many relationships. That is, the order collection has a composite key of receipt number, order number, with receipt number being the primary key of the collection table and order number being the primary key of sales order table. Similarly, the M2M relationship between sales orders and items is implemented by the means of item ordered tables, which also has a composite key, formed by taking the primary key of sales order and the primary key of item. The item ordered and order collection composite key tables both has the non-key attribute, but it is important to know that a composite key table to have no non-key attributes at all. No non-key attributes at all. So in that case, a composite key table is referred to as an all-key relation. Oh, another thing. Well, it is important to note that the relationships between tables are represented implicitly using foreign keys. By contrast, the older hierarchical and network models represented relationship explicitly using physical pointers. The process of designing a relational model in terms of number and structure of tables and keys linking the tables. It will be discussed in next chapter. Well, this is how you represent a data set in relational model and how to link each entity or event using the foreign keys. Well, next, let's see some table rules. Tables in a relational database must conform to a number of rules. Each table in the database must have a unique name. No two tables can have the same name. Duplicate columns and rows are not permitted within a table. No two columns can have the same name in the table, and no two rows can have the same value in every column. The consequence of rows and columns is immaterial. However, the convention is to list the primary keys at the left and the non-key attributes on the right side. Rows in the tables are usually considered in ascending or descending order of primary key. Although this ordering is not important or is immaterial in terms of database. Tables can easily be sorted on the fields other than the primary key. Every table must have a designated primary key, which is the unique identifier of every row in the table. The primary key could either be one field only or more than one field taken together. As discussed earlier, when multiple fields make up the primary key, the result is referred to as a composite key. A table could have more than one unique identifier, but only one must be chosen as the primary key. For example, a student table could store both social security number and a university assigned student ID. The student table would, in this case, have two unique identifiers, both social security number and student ID. But only one can be designated as the primary key. Relationships between tables are represented using common fields between them. As discussed earlier, these common fields are foreign keys. Recall that a foreign key is either an individual element of a composite primary key or a non-key attribute in one table. That is the primary key in another table. So, as discussed above, the customer number field in sales order table in the relational model is also a primary key in the customers table and is thus a foreign key in the sales order table. The rules for table is summarized in this slide. Well, next, let's see. Entity integrity and referential integrity. What do they mean? Tables must conform to a number of integrity constraints. Here, there are two key constraints. They are entity integrity and the referential integrity. Well, entity integrity means that a primary key field in a table cannot be null and must be unique. This integrity constraints applies to every table in the database. What entity integrity simply means is that the primary key field must be a value. Or in other words, it cannot be left blank. Well, for some non-key attributes, the value can be left blank. It is called null value in database. But for the primary key, it cannot be left blank. Or in other words, it cannot be the null value. Furthermore, the value of every primary key in the table must be unique. Otherwise, it cannot be uniquely identify one record, right? Well, in the DBMS, if you are against this integrity, the system will signal an error if the user attempts to insert a new row without specifying a value for the primary key field, or if the value specifies as a duplicate value. Next, referential integrity. Referential integrity means if the foreign case must be either a null value or match an existing value in the master table for the foreign key. It is important that the foreign case can only be null when there are non-key attributes. It is perfectly legal for non-key attributes to be null value. But a foreign key can never be null when it is an element of a composite key, because a null value in an element of composite key would violate entity integrity. Well, referential integrity is best explained in the context of an example. Consider a relational model in the figure represented earlier. Here it is. The customer number field in the sales order table is a foreign key. The customer number in sales order table is a foreign key because it is non-key attributes in the sales order table and is a primary key in the customers table. What referential integrity requires is every value of customer number in sales order table must exist in the customer's number in the customer's table. In other words, there cannot be a customer number in the sales order table that doesn't exist in customers table. Simply put, you cannot have a sales order on a non-existing customer. The customer table is considered the master table for the customer number foreign key. That is, every new customer number must first appear in the customer table before it can appear anywhere else in the database. However, referential integrity allows a foreign key field to be blank or to be a noun value. For example, a noun value in the customer number foreign key field in the sales order table must signify a cash sale. So that means it is not necessary to keep track of the customer number. Referential integrity also applies to region number fields in the sales order table. So, referential integrity dictates that all foreign key fields must have a corresponding value in the master table for the foreign key field. Entity integrity and referential integrity are essential to ensure an error-free database. Entity integrity prevents tables from having duplicates or missing primary keys, which would prevent rows from being located and queries from being answered. The main purpose of referential integrity is to ensure the validity of foreign keys. As discussed earlier, foreign keys are how links between tables are implemented. If referential integrity is not enforced, the relationships between tables may be corrupted because of invalid foreign key values. Well, these are two integrity in database. In addition to integrities, we still have data validation rules. The purpose of these validation rules is to prevent erroneous data from being entered into the table. They emphasize on the word to prevent. These rules are aimed at prevention rather than detection of errors. So, validation rules in database presents an opportunity for the data inputs to propose a wide range of controls that can be built into the system to prevent errors from creeping into the database. Let's first discuss examples of data validation rules, and then let's see how they work to prevent the errors. Validation rules can be established from individual fields within a table to restrict the data that can be entered into the fields. Rules the rules refer to more than one field in a table, can also be identified either directly at the field level or in some database systems at the overall table level. Data validation rules at the field level can be specified to ensure that the value entered in that field is in a range of acceptable values. Minimum values, maximum values, and both minimum and maximum values for data can be specified. For example, and where hours worked field can have a minimum value 1 and a maximum value of 40, or both constraints greater than 1, greater or equal than 1, and less or equal to 40. If the user attempts to enter a value of 50, well, in this case, the system will reject the input and display an error message. Another type of validation rules allows valid values for a field to be specified, such as data input is accepted only if it matches one of the acceptable values. For example, a shipping code. A shipping code field may be designed to accept only one of the following values, S or O, where S means in state and O means out of state. So if an user attempts to enter a value other than S or O, an error message will be displayed, and this input will not be accepted. Rules can also be specified to ensure that a correct number of digits have been entered into a field. For example, a zip code field can be designated to accept exactly 5 digits or exactly 9 digits. Rules can also be specified to ensure valid relationships between fields. For example, a sales order table with the fields order date and ship date. A rule can be specified to ensure that ship data is always on or after order date. While some database system allows such rules to be specified in either of the two fields, some other systems refer to such multi-field validation rules as record validation rules. So, these slides summarize the data validation rules discussed above. Range test, validity test, length test, and valid combinations test. Restricting access to tables. Well, in addition to such validation rules that are defined to each table, access restrictions can be defined at the database level for controlling access to sensitive data, such as tables containing employee salary data. Most database management systems provide the ability to designate authorized and unauthorized users for tables. Certain tables can be made accessible to all users except those listed, or only to a small range of listed users. Unauthorized users receive error messages when they attempt to access a table which they have not been authorized to access. Well, another method of restricting access to sensitive data is to create a view. A view is a virtual table. A view appears to the users as a table, but it's actually a version of an existing table with some of the table's data hidden from view. For example, a view can be constructed for the employee table that hides the salary and home phone number fields. The rest of data in the employee table, such as the name, cell phone number, email address, would appear in the view. All users can be given permission to access this view, but only a few individuals would be granted access to the actual employee table. Apart from hiding certain columns, rows that contain sensitive data can also be hidden. For example, information pertaining to high-level executives can be omitted from the view by excluding all rows in the employee table where the rank field is higher than 8, for example. Here, let's assume that all top managers have the value greater than 8 in the rank field. Well, hiding of rows and columns can be combined in the same view. So here, to summarize, access to sensitive data must be restricted by first specifying which users can access sensitive data by setting the permissions, and secondly, by creating views in which sensitive fields and records are hidden. In a database management system, the data dictionary contains a variety of information about contents of database. In a sense, the data dictionary contains data about data, or the metadata. Data dictionary is not a single table in the database, but a collection of hidden system tables. The information stored in these hidden system tables comprising the data dictionary is useful both from standpoint of application development and database maintenance, and also from a control and security standpoint. Some examples of the kind of data contained within the data dictionary are names of all tables, the columns contained in each table along with their data formats, and the privilege held by each user authorized to access the database. By querying the data dictionary, users can locate all tables in which a particular attribute exists. Access to the data dictionary should be restricted to select systems designers and auditors who would find the need to refer to data dictionary for a variety of reasons. For example, an auditor interested in determining which users are authorized to read the customers table would find that information by examining the data dictionary. Or if the auditor would like to know how many tables contain the employee salary fields, the answer can be obtained from this data dictionary. Well, that's all of today's class. In the next class, we will continue on language for DBMS, which is related to your next homework. Well, briefly speaking, in the next class, I will show you how to use SQL to do some basic queries in the database. And here's the reminder. Before the next class, please download and install Microsoft Access, which is a component in Microsoft Office suite. access, please download and install it in your laptop. Well, before I leave, please let me know if you have any other questions. No? All right. If you have any more questions, please let me know by sending me an email. Or I will see you next week. Bye-bye.
Bye, Professor. Have a good day.
Yeah, you too. Thank you. Bye-bye.